Hello, Hank. How are you doing?
How are you, Yogesh?
Doing good. How are things in Austin?
Very good. I still have not confused sending an email to you versus my boss because you both have the first name.
I must say you have a very good boss.
Yes, he is.
Hey, Sakul. Hey, Charlie.
Hello,
Good
hello.
afternoon.
How are you? How are you all, Yogesh?
Doing well. How are you?
Yes, yes, fine, fine. Thank you. Yes.
What's going on, Charlie?
Hey, it's great. How about you?
I'm doing all right. I'm just happy that it's 4 o'clock Friday and where I am. So
Well, it's only 2 o'clock here, so I've got two more hours to go to catch up to you. But
2 more
it's
hours.
bright and sunny, so I'm not going to complain.
Yeah. It's a nice weather right now. Other than, I mean, if you don't have allergies and stuff, it's a great time.
Yeah, everything has started to bloom early in California because we had a couple weeks back, we had kind of a spell of warm weather, looked like an early spring, but it's cooled down since then. But the plants haven't caught up, so they're blooming.
Plants are confused. My azaleas have bloomed like 3 times already. They're like, is it, are we there yet?
What's going on?
Yeah, we here we don't get much cold. So I mean we do get good, but we don't get much freezing cold, and we got like two like 1 day freeze events, and that threw everything off.
Yeah.
All right, hey Varun, what's going on?
Hey, Yogesh. Hey, how's it going?
Good. I think we'll have a few outages today. Rama is under weather. Shubda took day off. I know. Drew has been working on the document. He's been exchanging notes with me, so he'll join. And we have Tanya and Suke.
Hey, Yogesh. Yeah, Drew should be joining. He just ended the previous meeting, so.
Cool. Did Rama join that one?
Yeah.
Hey, I'm here.
You're here.
So,
You're flying today, huh?
yeah, I flew today. Well, the weather was crappy this week, so I didn't fly as much on my normal day. So I thought, well, I'll just come in Friday. And it was cool. They had special food in the cafeteria for Friday, so I need to remember that. It was good.
All right.
But,
I think we have as much of a quorum as we're going to get today. Dean is here. Charlie's here. Varun, Suke, Tanya, Hank, Sapul. I think Suke, Anil is still out, right, this week?
yeah,
I think he was.
yeah.
Yeah.
And
He'll be
so
back
we're working.
Tuesday, Monday next week. Yeah.
Okay. All right.
But I think we can make some progress. I talked to him before he left, and I think we can make some progress in his absence. So I'm going to go ahead and share. And let's see, I went back and so we discussed And if this is okay, Yogesh, I'm just going to jump in and review some of the stuff that we talked about and follow up from last week, because I took some action items and did some work on the doc, if that's okay.
But it should be okay. I don't know if anyone had any opens, anything.
Oh, yeah, I'm sorry. I'm just ready to go.
All right, all yours.
Okay, so last week there was some questions about BMC based. And so, I said, hey, we've got to figure out what it means. And so I put, I edited this paragraph a little bit, and and fit this in. And so, if you all could take a look at this paragraph that I've highlighted, I welcome any, under bullet 5, if you have any feedback, that's great. But in particular, I added this. This is new.
Oh, actually, I'm confused. You are using the term in-band logging. By that, we mean both firmware and OS first, right?
Oh, you're absolutely right. Well, because we're saying, yeah, in-band, and that's the way Anil uses it, right? He says that in-band is firmware first and OS first. It's on the host.
Yeah. Since you're
It's
mentioning
out
the
of
race
band and
conditions,
in-band.
just wanted to be clear. Right. Race conditions typically, yeah. I think if everyone gets it that way, then it's fine. Yeah.
Yeah, I mean, if you have two things logging the same register, you got a problem. So you got to sort that out. But there are ways to sort that out. And so I'm just saying there's a silicon solution that involves, there are multiple ways to slice it. I'm being intentionally vague. I'm just saying somehow it would be.
So do you think logging is the best that we can say? Is it logging or so the race condition happens in when one agent is handling in a way that it can clear and other agent loses visibility, right?
Well, I think of that as logging, right? You're like reading the error logging registers, and then when you're done, you write
Yeah,
some register
yeah,
that clears the error.
yeah. I'm 100% thinking out loud here, right? So just want to make sure it is when instead of the in-band the BMC and in-band logging, you can say in-band agent or logging, maybe. Do you think?
Well, it could be the agent, or it could be firmware first or OS first, right?
Which are both agents, right?
I guess I tend not to think of firmware as an agent. I always call it firmware, but sure. Uh,
I see.
how about
Okay.
entities?
Either way. I just was trying to make it easy to read because we
Yeah,
are logging,
I see what you're
logging and
saying,
logging.
because I said, and I like entities, because it could be the firmware, it could be the OS, it could be an agent in the OS, it could be lots of, like in band, there's a lot of flexibility, and so I just want to say in band stuff. So is that okay if I say entities?
Yeah.
Okay. So if
Yeah, I
that
think that's.
paragraph.
Oh, sorry, I was just saying Yogesh and Drew, I think that's clearer because we had the logging and logging.
Yeah, no, I after I stared at him, I'm like, oh yeah, it says that. Yeah, you're right. Thank you. This is fresh eyes. It's good. Thank you. It's better for that. I'm going to mark this off then and just check it, and then I don't agree with this. I don't think. So we need to. I think what I need to do is probably I have thoughts about this. Like if you're talking about poison recovery, that has to happen synchronously for error containment. Um, if you're talking
Actually,
about
what is that sentence saying? I'm confused. The way it reads is kind of awkward.
I,
It talks about immediate handling for recovery and BMC latency and
uh,
availability. So it's trying to say because there might be latency on the BMC and BMC might be occupied for long time handling that error. Is that what it's trying to say there?
well, so there's this notion that oh, we've got to react quickly in firmware to prevent a crash or something. And the reality is that the way RAS features are designed, containment is the thing that has to happen fast. And no
Right.
firmware has to do its part, but hardware really has to support containment. So when you try to consume poison, you take a synchronous interrupt. When you try to put poison out a PCIe root port, you either ensure that the card will fail the operation or you DPC the link. That's the kind of thing that has to be real time. But if I'm talking about, well, I've got a high rate of corrected memory errors and I want to do a runtime row repair. Well, if you've got ECC that's worth anything, then you really have time. That's the way that RAS features are designed, that they're designed to give you some time to think about the problem and take actions. And in like a lot of times when we were designing them in my previous jobs, we were designing the system to stay up on the order of a month or two till we could coordinate a repair with the customer. And so that's why chip kill was so important to us, is because it gave us that time. So I
I
think this is a
think,
misunderstanding.
but let's hear this scenario. Let's say to avoid the race condition, uh, you have a single register, you expose it to BMC, and BMC harvests the error and shares it with OS through HEST, for example. If that is the path we are choosing to avoid race condition to expose the error to OS, in case of poison, you are still using the path, but OS, if it directly gets the poison information, it can react as soon as it's getting it. Now it's going through the BMC.
Yeah. And in that case, and that is the one thing I even mentioned on the right, is that the OS has to see the error, and
It's
it has
if
to.
it's
Yeah, so essentially, I think the essence, with the one example I can think of by this highlighted statement is that one, right?
so
If
it's
it's
it is if it is critical, if it's a data path, if it's an execution path poison, then
Yeah.
it's happening as soon as possible anyway. And there may be additional flags at the creation, but the agent OS that needs to knows it already. So I don't know what latency concern would there be. Now it's a non-execution. It's a patrol, so there's some kind of event. I don't think there is a race there.
Yeah, but OS.
Normally not. Could be. It's not like totally ruled out, but normally it's yeah. I mean, you can have a situation where you just petrol and you flagged it, and then you immediately after that, OS application comes around, tries to consume it, and say, okay, I consume poison. I don't know. It's not totally ruled out, but you know.
Yeah, I can put some words in there. I think between what you and Tanya said was good, and I agree. I mean, generally that shouldn't be a problem, and we should not put the BMC in the OS decision making path such that it forces an OS to wait for hundreds of milliseconds in an interrupt handler to decide whether the error is fatal or not. That's not right. So don't do that. So I think we could talk to that. But otherwise, the OS should just be able to get that stuff directly, and the BMC shouldn't be in the critical path. And we need silicon vendors to solve the race condition in a way that works that way. So that's good. I think between you and Tanya, I think I have an action. So if that's okay, I'll just come back to that and rewrite it to say that. Any objection?
That sounds good.
Okay, thank you. That was actually a really helpful discussion. And Suke, I've been going through the document as you do things and just accepting like if it's a comma or something like that, then it's like whatever, it's fine. I mean, if it looks like it's fixing the grammar, then but actually the comma was in the correct place. So this is called the Oxford comma, by the way, where it says running. And but in this case, I have a clause, but even in such cases, and that even in such cases is a distinct clause. So the Oxford comma doesn't really apply here. It was a subtlety. It's a trick of English. But this is actually, I believe, correct. Because what you're doing is you're saying, but even in such cases, the BMC, see what you're saying, even in such cases is kind of called off. I could say, but the BMC may be able to collect logs if it runs on a separate voltage rail. But because even in such cases, it's kind of an aside, you set it off with commas.
Sure.
So
Yeah.
in general, I love your edits because you're cleaning up all the crappy mistakes we've made, and myself included. In this one case, I think it was right.
All right, no worries.
And the Oxford comma is not always needed before the but. Yeah, it's a weirdness of English. Okay.
I wouldn't
Let's
say
see.
grammar notes are the main reason I come to OCP meetings, but now they're a reason.
Grammar's exciting.
It's important.
It is. And you see these T-shirts where commas are important, and they're
Yep.
Can change the meaning.
yeah. Okay, so I did need a period there. Okay, so I accepted most of Anil's comments where he formatted IMA bold, but I left where he added paragraphs so that we could go through each of these things and make sure that, I don't, maybe he just added a paragraph to put a space here. I guess if he did, he didn't change the wording.
I think that's exactly what he did. He just broke to a new paragraph.
Okay, or he put a space. Yeah, I think he added a space here. Yeah.
Just readability. He didn't change content.
Okay. I'm just going to accept those. Readability changes are great. We don't really. I don't think we need to talk unless you guys see a problem. Okay. So device firmware. Add text here. Does someone want to take the action item to fill out what device firmware means?
I can take that and sync with Anil too to see if there was any specifics. Can get
That'd
that
be great. Awesome. Okay. Thank you, Suke. Now, one thing, I looked at this one, and there are a lot of arrows in that drawing, so I was having a little trouble following it. And, it also assumes that SMM is involved, is what it sounds like. And let's see, I don't think I can get the picture. I can't split the window here, but see, I think he's talking about things here. He's talking about these arrows, I think. Maybe these arrows. I wasn't really sure. And, two possible paths. The arrows from hardware to firmware and then OS indicate firmware first, where the firmware intercepts the events. I don't know. Like what if we had a microcontroller that logged the error? Non-x86 processors often have that. And those processors, might be able to hand something to the bird or host.
Why is this under device driver?
I don't know. Did I delete a header by accident? Oh, no, I didn't. I'm going to redo that. Redo adding my comment. Okay. I don't know. Oh, this is weird. Oh no, this paragraph just needs some more. Suke, can I give you the action item to maybe take a fresh look at this this paragraph along with your other device
Yeah,
firmware?
it's close enough in proximity that I won't miss it.
Yeah, and if if you need to chat, ping me and we can chat and I'll but I think something just doesn't look quite right here. Thank you. Okay.
Drew,
And
this
then
next section about PCI, I think we need to think about this. We are going and flying at a very high level, and all of a sudden we just go deep into PCIe and start referring to Google's documents and some other documents. I don't know if that's the best way
I have a
to.
proposal. Why don't we come, is Anil going to be back next week?
Yep.
I'm sorry.
Yes, yep.
Yeah, so why don't we skip this section and have that discussion when Anil's here, because I believe he added this and I can't speak to it. So is it okay? Because I want to also show you
Yeah,
I did some work on the drawing, and so I was thinking maybe we could spend some time looking at the drawing and seeing how
yeah,
if you so is that okay if we just skip that for the moment and come back to it when Anil's here?
let's do that. I
So
left a
here,
comment there though on that drawing. Thanks for sharing. Yeah.
yeah,
Updating it.
okay, and here's the old drawing, and Anil's like, "This is ugly. Drew, can you clean it up?" And I agree with him. It's ugly. So what I've tried to do here, and I'm just going to I'm going to walk through it at a high level. And then I haven't seen your comment because I've been in meetings, Yogesh. So then we'll jump to your comment. But what I did is I cleaned it up and I left most of this alone. One thing I did though is I just said there'll be a cloud provider control plane. And that way we don't have to have all the arrows going all directions everywhere. That just was a little much. And so I really cleaned the drawing up. I also cleaned out the BMC because when we originally did this, we were told by OpenBMC folks, you must push everything through dbus to Redfish, and you do it through this hardware fault monitor and send your error logs this very specific way. Well, we've since evolved the RAS API conversation a gigantic amount to the point where we have the RAS API protocol, and we'll have a mapping for MCTP, and we'll have a mapping for Redfish for it. So I just cleared all that extra cruft out and just said, we've got the RAS API, and the RAS API will talk to the BMC. It'll have some mapping, and it will communicate to these paths and enable these things. So I hope that's okay. Really simplified the drawing a lot to do that. And it's kind of reflective of what the RAS API is going to do for our lives, in my opinion. The other thing I added was we talked about header parsing. And so you got to decide, which analyzer analyzes errors. And we talked about time series and prior errors. And so I probably need to put some text describing this a little bit. I need to update the description of this drawing below. But I thought I better get the drawing right and get some feedback on it before I go too far. So, but my thought is that, if we're going to enable time series analysis, you get a new error, you parse the header, you go, oh yeah, it's for this analyzer. This analyzer wants the last 90 days. Here's the last 90 days of errors analyzer. And it goes and looks at the new error and says, oh, I just need this, I'm done, and can send a CPAD, or I can look through the 90 days as it wants. And it will send CPADs. The CPADs then go through our policies, and we either decide to drive repair automation with it, or we drive some message back to trigger a RAS action. So that's the gist of what I did. And I put CPADs in explicitly and CPER. So you see CPERs coming in and CPADs coming out. And with that, Yogesh,
Yeah, that looks good. I think I'll let Vilas also chime in if he wants to add something, but I think it's pretty complete. My comment, I think it's kind of you can go through it, but it's
just hard to look at the drawing and your comment at the same time.
Yeah, no,
Let's see.
that's
IMA interface infrastructure. Yeah. Yeah. So I'll be honest. I texted both, the two of you just to make sure I didn't screw it up with our RAS API conversation. And I struggle a little bit because the RAS API may be here, but it might also, like if you look on this side of the drawing, I've got all this silicon, different types of silicon, and the BMC, all of which can pass data up to the RAS API. And they're all abstracted by the RAS API block. And in this case, I've got a RAS API endpoint for the kernel, but not the device driver. So it's an incomplete abstraction. But isn't the point of the RAS API to make it so you can see all the data from all the hardware? So should the RAS API be right under the in-band management agent, or should it be lower in the hardware and the kernel and the device driver talk to it?
And it will vary by implementation. I think you could make like a shim between the two, IMA and vendor code, and that's your RAS API interpreter kind of thing. Yes, Vilas, sorry.
No, yeah, sorry, Drew. I did look at it again. I think it should look more like the BMC, and there might be multiple RAS API endpoints or one endpoint, but like the control plane should be talking to the RAS API, and then under it should be the kernel and the device driver and whatever, right?
So I could. I'm not going to move this now. This drawing is so hard to edit. I spent like hours. It doesn't look like I spent hours, but I spent hours moving blocks around. Okay. I mean, like I could put the RAS API endpoint, here, but is that right? Or your point is there could be multiple. There could be, is it above the device driver though? Like, is it more right to have a shim that goes all the way across, or is it more correct to have one that, says, well, every device driver can appear as a RAS API endpoint?
So bottom line is, if we try to capture all potential implementations, we will have a very, very complicated drawing, which RAS API endpoints all over the place.
Correct. Yeah.
Yeah, but I'm really just trying to ask some fundamental questions about how does the RAS API map to in-band? Because my mental model is that the RAS API would be down here.
Oh no, I don't think so. No.
And it would get all the GPU and OS stuff and somehow surface it to the kernel, and the kernel would surface it wherever it needed to go into the agent. So
I looked at the IMA definition again, because I had the same confusion as you do. And the IMA definition says that's an interface to the cloud service provider infrastructure. If that is the case, then it needs to at least comprehend. And I'm still debating what do you mean by endpoint. I think it needs to have awareness of RAS API in some way. It could be an extension, it could be multiple extensions, but basically it's a RAS API aware interface.
Yeah. So the IMA, I mean, that's right, Yogesh, right? The IMA is a RAS API agent, right? Exactly how that gets implemented now is, does it then just, know how to talk to the device drivers, or is there some, maybe there's a second layer, like you've got it drawn there, where there's a kind of vendor specific one, that is a detail.
I think of it this way. On the BMC side, I can write a universal collector, theoretically, that can go to the BMC and say, hey, do you have the RAS
Yeah.
API? And he goes, yeah. And I'm like, what you got? And it'll tell me all the stuff that it's got. And now I've got one point that I have to talk
Yeah.
to. So I can write that universal collector.
That
But-
one point in bend side is IMA. All you
That's
can
right.
do is make the top box, call it a RAS API aware IMA, and you're done.
That's right.
Well,
Yep.
I guess what I would say is that I'm writing the IMA. The problem I have today is that I don't have a standard way to talk to all the different drivers to get
No, but-
these things done from it, right?
But
So-
you don't need one necessarily, right? So I think of like how to talk to the device driver. That's effectively
like-
a transport.
Like, let's say this. Let's say that
No,
a
but it's effectively a transport. So
I don't understand, but let me walk through an example, a real simple example. A GPU has an error and generates a CPR log. Okay, so it's a RAS API endpoint, down here.
no. Yeah. Okay. But I would just say it this way. One thing that conceptually, the device driver and the GPU are all one thing. They're all one thing, right? They're all like how the
Oh,
specific.
I'm fine with that. I'm fine with that. I'm
Okay.
not debating that. So,
Okay, yep.
but let me walk through my example though. Okay. So now I got a new GPU from Motorola
Mhm,
in my data center because they're back in the game,
mhm,
and I've got an error log that comes from
Mhm.
it. And
Mhm.
you could argue that, okay, sure, the GPU and the device driver are the same. I buy that. They're tightly coupled. Absolutely. Hard to separate. Impossible. It won't work. So now the error log, their data comes to the device driver, and that seems pretty obvious for the in-band path. But the problem I have is that I've been writing all this custom code for Motorola or for NVIDIA and AMD and Intel drivers, but I don't have a Motorola driver. Now, do I have to completely rewrite my in-band management agent to collect that?
No. We have to define a transport layer for the device or the device driver to talk to the RAS API agent on the node.
So
That
then
could-
that argues that there's kind of a RAS API endpoint in the driver that
No, well, yeah, I would potentially, yeah, exactly, right. But the in-band management agent's also a RAS API agent in that case.
Yeah, it could be, but I guess,
Yeah.
I mean, that's kind of an important point is that the driver, like we want the driver to have a common way to communicate with the in-band management agent. So the in-band management agent can go to the drivers and go, hey, are you a RAS API endpoint? And it goes, yep. And you're like, cool, I
That's
can
right.
speak my protocol to you, right?
That's right. Yep.
Okay, and so then it's the same thing with the, kind of the kernel errors and stuff. I mean, the SOC errors that come up through the kernel. The RAS API is kind of actually in that driver.
Yep. So I'll just say that's one way to do it, right? We could decide as a matter of implementation to do it a different way, which is, that IMA is a RAS API endpoint. And let's say, for example, that it's, I'm just going to use Linux open source for now as, the thing.
Sure.
Motorola.
Yeah.
Motorola, in this example, just upstreams code that says, "Hey, I'm telling this agent how to talk to my transport layer," right? And then the cloud service, the cloud provider control plane is none the wiser. It's just talking to this RAS API agent. This RAS API agent says, "Oh, look, I got a Motorola transport layer here," right?
Yeah. Well,
And
I
it
mean,
goes
like you had talked about that, right? Because
Yep.
like this could be a RAS API endpoint that talks to RAS API endpoints.
Correct.
Sir,
So
one
both
quick
of-
question though. So BMC is the out-of-band agent that's hosting the RAS API, the green box.
that is one possible
In this
implementation.
drawing.
No. In this drawing, that's one possible implementation.
And that's the way I
Right.
like it.
Yeah.
And similarly, the in-band agent
Yep.
can house a RAS API like this. right?
Correct.
So the
Correct.
in-band agent is not an endpoint. It's something, whatever BMC is doing on the out-of-band, something similar on the in-band side. and rest
Yeah.
of the stuffs are endpoint.
Yeah, I would probably remove the term endpoint and call them all RAS API agents for now, Drew, right? We haven't maybe fully settled on exactly how that all works, but yeah.
I mean, but like down here, this is an endpoint, right?
Just call them all agents, right?
Even
Like,
down here.
yeah, even down there, right? Like agent is just an entity, right? Some of them might be endpoints, some of them might be switches, some of them might be initiators. Like it's a detail that we don't need for this drawing, right?
Okay. Well,
And
agents.
and we haven't fully, I don't think, agreed on exactly whether those are different things or not, right? Yeah.
Oh, okay.
And
So
the BMC, same thing with the BMC, just RAS API agent, right? I also, yeah. So for this drawing, I would recommend that you do not have the RAS API agents, the two in the vendor code there. I would recommend that you do not have that, and you make the in-band management agent. That's a RAS API agent, and you just
that
leave the
sucks,
one.
though. I mean, if I guess we need to talk to Anil, but if I was Anil, I'd hate that because now I have to. That's making me think I'm going to have to write a in-band management agent that has to know Motorola driver to speak to
I mean,
get air logs from it.
no one. I mean, that's you don't have to, right?
Well, if I want to get air logs from them, I do.
Drew,
Out of that
so
agent.
Drew, consider this. You get a communication from your cloud provider control plane to IMA. How would it know that this entity, IMA, that I'm talking to, talks RAS API or not?
So I think it's just the same way you do with the BMC. You make a request to it, it responds to that request. We've just mapped the RAS API protocol.
That's what you're asking to,
Yeah,
right? On BMC,
right.
you have RAS API agent. Same needs to be on the in-band agent, right?
But Drew, the thing that you're responding to is the lack of standardized transport layers on the in-band side. That's it's a kind of a separate problem. Like the BMC, right? The BMC right now, in order to talk to all these things, has to know PLDM, has to know PECI, has to know APML, has to know, CCI. And over time, hopefully that'll reduce, right? But there's a set of kind of well-known transport protocols that the BMC can use to talk to these devices.
Yeah, and then we map a protocol to we lay our protocol on top of the existing things to talk to an agent.
So on the device driver side, there's not a standardized transport layer that's similar to that.
I agree.
Right. But I want to point out that's a different problem. Right. So that's kind of what I'm saying. Right.
I agree, but I'm looking out for Anil. If I was Anil, I'd really want this because the IMA is going to be painful to write if I don't have a standard way to talk to drivers.
I understand. And I think we should think about if there's a standard way to talk to drivers, right? I mean, that's an open problem that I think we should solve. And I'm also saying, right, it's perfectly fine to do it the way you have it drawn right now, where there's a RAS API agent at the top, and then each of the drivers or the driver or the kernel or whatever exposes a RAS API agent. But that's also fine, right? It's just the drawing gets super messy if you have that many RAS API agents in it.
Well, what I can do is the same thing I did with these, right? Just put them inside it.
If you want, I think you start to lose the forest for the trees in that case, because you end up with so many different RAS API agents that it gets a little bit,
And the
confusing.
RAS API agent that we have in the BMC, that same RAS API agent is everywhere in this picture. So wherever I see RAS API agent, I should assume everything in BMC is in there.
Again, we're still working through the definition of that, right? But maybe.
Yeah,
maybe not.
I think what's on the BMC is different than what's on the endpoints personally, but I'm suspending disbelief for the purpose of getting the drawing.
I think it depends on your definition of everything. I mean, we're talking of many
RAS config, CPR error logs, RAS action, error injection plugins, right?
That would be somewhat of a platform configurability aspect also, right?
So I have a naive question because I did not participate in the RAS API group. The function of the RAS API is what? To receive requests of a standardized format, if not
Well,
content, and then
it's
emit actions down the bottom.
no,
like-
it's to provide, it's to do these things, to provide an interface to configure a machine, to have a place to grab error logs, and a way to drive RAS actions. And
So
error injection is a RAS action.
The requests to do that are standardized, right? That's the whole point.
That's right.
And
Yes.
there are CPADs, and
Yep.
I don't know, maybe there's
And
other.
and the protocol for there's some protocol for discovering. So if I can go to the BMC and say, what do you have? And it'll go, oh, I've got 8 GPUs and an SoC and a NIC and a whatever. And so now I know what's in the what's behind the BMC, and I can say, do I have an analyzer? And I might be able to go, oh, Motorola made a new SoC.
Right, don't go that far. Let me stop you. So the RAS agent, excuse me, the RAS API is intended to cover not just one device. It
Correct.
could be implemented that way, but it's for the system, because you just said you're asking, tell me what you have, how many of these you have, how many of those you have. So it's sort of a
Yeah.
system level. So it's above the device
And like
drivers.
if I have 8 GPUs and one of them sends an error log, I need to say, do I have an analyzer for that GPU? And so let's say when the machine woke up, I connected to it, made sure I had an analyzer for it. Now it sends an error. So it's one of the 8 GPUs. It will come up here through the BMC, out to the header parser, go to the GPU analyzer, and then send an action back. And the action comes all the way back here. And now I've got to send that action back to the right one of the 8 GPUs.
Good.
So the RAS API is intended to allow you to go the full circle, right?
So
can
you want that
discover
same
what's there.
level of same kind of functionality on the in-band side. You don't want to identify individual devices. You
That's
want the
right.
RAS API to do that.
That's
Yeah.
right.
Well, and like if you think about it, you talk to the BMC and the BMC discovers the things it can talk to. And so in my mental model, you talk to the IMA and the IMA discovers the things it can talk to.
That's right. Yep.
And so that implies that there's some RAS API functionality that we're adding to the things so that it can discover them in a uniform manner.
The in-band management agent is intended solely as a connection point for the data center's communication, but it's not a system management functionality, right? It doesn't understand the platform. Is that right?
Well, I mean, like if it's it has to a degree, because if you're gonna log errors from it, you gotta know what you're logging errors from, right?
Well, no, hold on.
It's just a
Dean,
pass through, I thought.
well,
Yeah, it can be passed through, but you need to know it's there.
Well, hold on. So Dean, like just from a pure protocol point of view, right? It could be passed through, but it could be stateful, right? Either way, it could be either or, right?
Yeah.
It doesn't,
Okay.
right? Like it could have its own set of queues that exposes to the data. If it's passed through, then the data center has to know, oh, this node has like 10 things under it, right? It
So
could
that's,
be. Yeah.
I'm surprised you just said that. So you're saying that the in-band management agent could be the system management entity.
Correct. Yes.
Oh, that's not what I expected at all. In fact, I'm
Well-
not sure you guys agree with each other.
No, I do. I don't think of pass through quite the way. When I say pass through, I just mean it's not smart. It programmatically discovers their error logs, and it can have queues, but it doesn't really think about them. So I'm thinking more of a software development. It's scalable as pass through. So I can standardize around. I can go with VLOS's notion of pass through. But I think that the way that it ought to work is that you say what you have, and it tells you what you have.
The way that it ought to work is an implementation statement, and that's fine, right? All I'm saying, if the BMC is passed through in my language, it's part of the transport layer, or sorry, not the BMC, the IMA. IMA is passed through, it's part of the transport layer, and it's communicating packets between the data center and the device driver that implements the RAS API. If it's not passed, the data center is communicating packets to the IMA. The IMA is saying, oh, this packet is destined for this device driver. I'm going to go send it over there, right? Those are two different things. It's part of the protocol.
I think there are different layers of pass-through, because I think queuing, directing
But
queuing is
it's
pass-through.
fundamental to separating the protocol from the transport. That's a important thing. Both of those things are possible. One of those implementations is likely better.
Because
Yeah.
your system management understanding and functionality is either up in the data center for pass-through or down in the IMA for non-pass-through.
That's
Is that
Yeah,
correct?
and what you're doing
that's
is,
exactly
if
right.
you're,
Yeah.
if,
that's
if,
exactly
yeah,
right.
and if you're doing VLOS's pass-through model, what he's calling pass-through, you're sending things independently up here and praying you can join them together later. And I really don't like that. I think it's better to say, hey, I see an error condition. Anyone else have errors? And send them all as one pile.
Yeah, I understand you, right? I get it. I'm just saying, as a statement about the protocol, right? That's an implementation choice.
Okay. I think there's a bad implementation choice and a
That's
good one,
fine.
but I
That's
agree with you.
Oh, yeah.
So
I'm
I
not
think
disputing that
Vilas's
at all.
whole point is we are describing the protocol which enables you to do what you are asking.
Yeah.
So
That's right.
there's no contention there,
Yeah.
right? It's possible. It's absolutely possible. But protocol is not saying you must do it this way. That's the distinction.
Yeah. But
That's
I guess, and so I
So back to what I was trying to say, right, Drew? There's a couple of ways that this can be implemented, right? One example is the IMA is the RAS API agent. That's the thing that you like as the best implementation. The device driver could be basically part of a pass-through, part of the transport layer to a RAS API agent living on the GPU. Or the device driver could itself be a RAS API agent, and then it talks to the GPU in whatever way it wants to talk, right?
yeah.
Both of those things are right.
Well, I agree. One nuance there, Vilas, is that since we haven't defined agent, I think there has to be some protocol map for some protocol for the IMA to discover the drivers that can
No,
speak to its API to it.
It has to discover the devices and see if those devices are RAS API capable or not. Whether that device discovery, it goes through the driver or through the device itself or through the kernel, that's all an implementation choice, right? So that just it's going to depend on the particular transport layers that are specified. But again, this is all, first of all, there's bazillions of details we haven't worked out there. Second of all I'm trying to suggest is that we don't litter this diagram with boxes that say RAS API, because you end up losing the forest for the trees.
Yeah.
That's like literally the only thing.
If your first interface and last interface are RAS API, where you'd assume everything in between is too. Otherwise, it could be stateless, stateful. That's all implementation, right? That's all details.
That's right.
So
yes.
Now, one more thing to complete, and I think we should close on this drawing. This is pretty good. Drew, thank you so much for cleaning this. This looks much better than what it used to. The cloud provider control plane, that's excellent, smart idea. It solves so many, cleans up the document so much. But I think you may want to put a RAS API agent in that box.
I want a collector in that box. I don't want a RAS API agent. I mean, maybe depends on what we call a RAS API agent, but because we don't want to do joins in the cloud. That's what I want to see is a blob of data.
From protocol perspective, if one end is talking RAS API, your other end needs to comprehend RAS API.
Yes,
I
agree.
Yeah, I need to think about how to put that in, because I don't know how to do it, but I agree. I guess what I could do is I could put a slice on another thin box that says RAS API, agent.
Or IMA, right? Inside that box next after the plane, you put it in the brackets, like just say RAS API.
If you do that, then you're implying to the right of that, you have to create yet another protocol, and maybe it's specific to the data center.
It is,
but why do that? Why not make RAS API your protocol?
I can explain that. That's a no-go. So basically what happens is all the cloud providers have a giant infrastructure that already is doing this, and well, they're not going to completely change it. They don't really need to. All they need is a collector that feeds into their infrastructure, and the plumbing back will probably be new, but they're going to implement it vastly different ways, and that's okay. As
Okay,
long as
that's a good answer. Thank you. Okay.
it's brownfield. That's why this is more, this is like a machine level thing, and that can change with future generations. And this is a giant thing that evolved over decades and is painful to change. So we just need to let them change it as fast as they can. Okay, so I agree. I think I could put a shim on that says RAS API agent. And then, but Yogesh, it's not just to the IMA, it's to the to this as well. It's to both.
Yeah,
It's
basically,
about- yeah.
your touch point towards the infrastructure side knows and comprehends RAS API. That's the statement you're making.
Right.
Yeah, there's some
And-
bridge between our infrastructure and the API. Yeah.
Yeah, I mean, again, I've said this before, like the cloud providers are free to implement that however they want, but at the end of the day, seeking RAS API, speaking RAS API to something that understands it, right? And,
Yep.
Right. So.
Yeah, I agree. Okay, I can fix.
Just since I'm not in the RAS API discussion,
You should join us.
there can be a so in this case you are showing in-band and BMC cloud service provider, but let's say for a BMC is not available, then everything should go through in-band RAS API, right?
Or some agent on the machine for out of band. I mean, you could have a rack manager that spoke to each machine too somehow. I don't know. I mean, but if you don't have the BMC, if you don't have an out of band path, then you have to go in band. Yeah.
Right. Yeah. So whatever we have on the BMC side, something equivalent on the in-band side, both of them are capable of looking at like with discovery capability. Are you RAS API compatible? Yes, no. If yes, then blah blah blah.
Yeah, and we really need some notion of of the ability for the agent to discover that and and expose everything upwards. So just like the BMC needs a way to do that. Yeah. Okay. Well, my head is stretched, but that was a good discussion. I will, excuse me. I'll work on the drawing some more, but I think I'm way closer.
On the in-band side, just again for purposes of the drawing, I would get rid of that RAS API agent above kernel error handling driver, right? So just make it match.
Yeah, we don't need it in there. Yeah, you can drag that box on the control. Yeah, on the other side, the control plane.
I'll just redraw it because I'm going to have to turn. I'll have to go with it. Adding the clean. I'm just going to slap this on. I have to zoom in on a big monitor to get the lines straight, and you don't know what a pain this is. Anyway,
Nothing is straight on the in-band side. We all know that.
and hey, if it was easy, they wouldn't pay me the big bucks to make drawings. So let's make it hard in every way possible. But so
one other just drawing cleanup suggestion, Drew. I understand why you have a line between the SoC and the kernel directly. Could we move it in such a way that the device driver and the kernel in the vendor code box are next to each other, and so it's very clear that they're mirroring each other and performing the same? You know what I mean?
Oh, you mean like deal with this arrow so I can put them beside each other?
That's right.
I'll see what I can do. This is a Neil drawing, so but I think I can. You know, like I touched this side way less than I touched the right side. But yeah, I'll give it a shot.
Okay, thanks.
And what I'll do for the moment is just get ready for ugly. is I'll do this to remind myself.
We should probably just make a one box for all the drivers. It's just color driver, device driver, SOC.
Yeah, I can make it. I can make it work.
Yeah.
I'm not worried. I'll make it work.
Yep. I mean, you could even put a firmware box between the GPU and the device driver, because in reality, that's what's probably going to happen. And it would be totally the same.
But that's an implementation choice, isn't it?
So is this one. But yeah, I mean, they're both implementation choices.
Yeah. But I'm just saying, I don't really care. As long as
I don't care. Just, I'll just say it this way, right? The more similar that different devices look on this drawing, the more it'll drive the point home.
Okay, I see. So you're saying, so that's why you're saying I can put the firmware box. Okay, Anil, please forgive me. Suke, tell Anil I'm trying to represent his interests.
Oh yeah, I'll recap this meeting and
So-
Vilas'
sincerely,
suggestions
I'm sincerely,
in your defense.
Yeah.
Yes, I'm sincerely trying to help.
Yeah. But
Okay.
again, right, like the forest here, right, is that the infrastructure is the same between vastly different underlying devices, right? And showing that pictorially is that's like the thing that I think we should try and do, right?
Yeah, I mean, that's it. Universal
Yeah.
collector. That's what I keep
Right.
telling people. The plumbing should be just absolutely universal. Why do we need to keep reinventing it?
I think that's a good point, and it goes back to Tanya's repeated questions. The more the left side looks like the BMC, the better off we are.
That's
Yeah,
right.
Yeah.
So
I would
kudos,
say that's the
kudos,
best-
Tanya.
I'd
Take the
say
rest of
that's
the
a-
weekend off.
I think I was going to say that, Dean. That's a great dream to end the weekend with. Week with. Start the
Well,
weekend with.
I have to say, it is absolutely amazing to me that we have this much alignment. And if we can make this happen, it's going to be just so huge. So thank you all. I really, really appreciate your help doing this. And, I feel like we've converged on something pretty big here.
And
think-
one more question. Is there a reason we are calling out firmware box separately?
It was there. That's my answer.
Is the API,
Do you
RAS
think-
API agent a firmware construct, or it has to be a hardware construct?
Yeah,
Well,
it could be either. So maybe a different way of doing this. So this is a good point, Tanya, right? Instead of having the firmware separately, have it within the SoC, right? Like just have a
Right.
big box that has SoC and it's got hardware, firmware, whatever, right? And the same thing with the GPU. It's got hardware, firmware, whatever, but the device is exposed to that. Yeah, I agree.
Yes, you're right, and that's actually a cleaner implementation. I actually really agree with that. That firmware should have been in them.
Yep.
I'll do that. Just making it look ugly on purpose to remind me what I need to do. Welcome to the ugly.
Oh, wait,
But,
which boxes are you putting the firmware in? I thought you're putting it
both.
in.
With every hardware, the firmware, we are just putting them together, hardware, firmware, basically.
So the SoC has the boot time, runtime firmware. That was the error that came from it, and then I added a GPU firmware. So, and I can get rid of some errors that way too. So, and I can make them look the same to Vilas's point, and that will, like he said, drive the point home. I'm quoting you, Vilas. I agree with you. So okay, I can do that. I can clean that up and make them. They have both the RAS API agent in them, and then I'll put firmware on the top, and the firmware goes to the kernel or to the device driver. Wow. Now my head really hurts, but this is good. I mean, it hurts in a good way. Well, it's been stretched here. Thank you.
Okay, good
Cool.
time to end today's call. Thank you all for great discussion.
Yeah, I feel like we're making progress. And Suke, if you can prepare Anil for the changes, that would be awesome. And then if he has any concerns, I'm happy to chat offline. We'll have to set up a time. But we are really sincerely trying to work on your requirements here. So I know that we're doing this in good faith.
Will do. Yep.
Awesome.
Have a good weekend.
Yep.
Talk to you soon.
You too. Thanks again. This is a really good meeting. I really appreciate it.
Thanks. Bye.
Yep, thank you.
Yeah, thanks.
Thanks.